Let's walk through the first example from the article. This is a pretty complicated pipeline, but if you imagine all the objects as physical objects, like ping pong balls, you can kind of imagine what it's going to do. GetProcess is going to retrieve a bunch of processes and put them into the pipeline. The pipeline character takes those objects and passes them to the next command, in this case, whereObject. It's going to look at each object. The $_ variable represents each object that's in the pipeline, and this script block will execute once for each object that's in the pipeline. So if there are 10 processes, then this script block will execute 10 times. Each time it executes, it looks at the current object and compares its VM property to 1000. If the property is greater than 1000, then the object is put back into the pipeline. If it's not greater than 1000, then the object is taken out of the pipeline and discarded. So for everything that's left in the pipeline, they're then piped to sortObject, which sorts them on that same VM property in descending order. They're placed in that order into the pipeline and sent to the next command, which is export CSV. That changes the objects into a text file and stores them in C procs.csv. So if we run that command, give it just a couple moments to complete, we can then use Notepad to open procs.csv and see that it does contain all the information that we asked it to. Not every process is in there. Only processes which were using a virtual memory more than 1000 were included, and they're sorted in order of their virtual memory utilization. So the next example is a little more complicated, so let's look at a script for that. This function is a filtering or a pipeline function. Now the begin block will run automatically the first time the function is called, and the end block will run after all the pipeline objects have been processed. The process script block will run once for each pipeline object that's sent in. So here's on line 11, the first actual executable line of code. GetProcess is going to retrieve all the processes, put them in the pipeline, and then send them to the doSomething function. For each process, I'm going to create a new PS object, add a note property named timestamp to it, and that's going to contain the date. And then I'm going to add another note property named process name. In it, I'm going to take the current pipeline object, which is a process, and grab its name property. That custom object is then written to the pipeline, which means it is then passed to format table, which is being asked to display all of its properties. So if I run this, we can see that the output is indeed a table with a timestamp property and a process name property. Those are the two properties I created. The last example in the article is a lot more complicated. Let's start with the executable code on line 19. I'm going to retrieve the contents of a file named computers.txt, pipe it to a custom function named getUserInventory. So let's go see what that's doing. If computers.txt is laid out like this, with one computer name per line, then the pipeline object, $_ is a computer name. So I'm setting a variable users equal to getWMIObject, Win32 user account, from whatever computer name is in the current pipeline object. Now that can return multiple local user accounts, so for each user that was returned, I'm going to create a new object, add a note property named computer with the current pipeline object. That way I'll be able to keep track of what computer this account came from. I'm adding a note property for password expires, disabled, full name, lockout, name, password required, and password changeable. And each of those properties is simply being populated with some of the information from the WMI object I got back. The main reason I'm constructing a custom object instead of just outputting these properties directly is because I want to add the computer name to this object. That's a property that's not present in the WMI information. So I'm constructing a custom object that includes some of the WMI information, but which also includes the computer name that the WMI object came from. The last thing I have to do is to make sure that I write this object to the pipeline. So that's what comes from get user inventory. The next thing I'm going to do is filter those out. So I'm going to take all the objects out of the pipeline and only keep those where the password required property is equal to false. Of whatever objects are left in the pipeline, I'm going to keep just the computer and name properties. So that's the computer name and the user account name. So that's all that's in the pipeline at this point. And I'm going to export the remaining ones to bad_users_bad.csv. So this becomes a report of all those user accounts which are not set to require a password.